Right, let's see if this is working. It's partially working. Hold on, my Stream Deck is not running. Hold on, let me fix that. There we go. That should do it. Let's hope the audio is not going to cut out on us. No, we're okay. I thought for a minute I'd got it wrong again. No, so we're good. So, what we're doing in this stream, we are going to have a crack at adding support for KiCad. Adding support to what for what now? What are we trying to build? We're trying to do pick and place machine software, which puts parts on circuit boards, and those parts are defined, the positions where they want to go are defined in an EDA tool. The initial EDA tool that we used is called DipTrace. It's the one I've been using for a number of years, 10 years or so now. Yeah, it must be. But lots of other people use KiCad. Back when I started looking at EDA tools, I don't think easy EDA even existed back then. It might have done in some form, but it wasn't as prominent as it is today. DipTrace was fairly intuitive. Eagle was horrible. I didn't like it. I didn't get on with it because the way that my visual learning brain works. And KiCad was around, but it was only like version 3 or something. So I went with DipTrace and was productive, and it was fine. But apparently KiCad has come a long way, and it's on KiCad 8 now. And yeah, here it is. Here's KiCad 8. Ta-da! I have no idea how you use it. But we're not really interested in the whole thing about laying a PCB out properly or anything like that at this point in time. We don't care. We just need a very basic schematic and a PCB layout that uses the schematic that has some placements and components and stuff on. And then once we've done that, we'll be able to export the same kind of file that we've exported for DipTrace, which looks like one of these. Okay, so our goal in this video is to try and get one of these things out of KiCad, and then also write some code so that we can do the same thing that we're doing with the DipTrace file, but with KiCad, and we'll see how far we get with it. We haven't done loads of complicated things like sides and rotations and all this kind of stuff at the moment. It's literally just sort of like ref des and then like something which tells you about the part. So we just need to know what that is in KiCad, really. And we're gonna find out the hard way by trying to use it. So I've created a new project in KiCad, which is just this now. Literally just created it at the start of the stream. So we're going to try adding things to a schematic. Once I make it a bit smaller, there we go. Okay. I can draw lines. I don't really want to draw lines. How do we add a part? Is it one of these? Symbol editor. No, you see, it's fantastic that I can do all of these things, but add symbol. Ah, there it. Well, what happened there? Oh dear, it's doing things. Kevin, you'll be happy to know I've got my biscuit. Today's biscuit of choice is a lemon one. Nom nom nom. Okay, so we can apparently choose symbols. Interesting. Okay, let's go with resistor. Oh dear, I pressed the wrong button there and it started my music. I don't think you guys heard anything though. Okay, so resistors. Oh. Okay, that's not as easy to find an 0402 resistor as I thought it might be. No. I just want a resistor. Is it just resistor? Oh, I see. Okay, resistor, here it is. Okay, we're going to say whatever. And then we're going to say it's going to have an 0402 Imperial, right? Oh, I see. Right. Okay, fine. Yeah, that sort of looks like what we want. Okay. And we're going to go kaplop. Amazing. That's my first ever part placed in KiCad. You all witnessed it right there. Yeah. Okay, let's go back to, progress. Progress. Let's go back and see if we can load up dip trace. And then oh, I've got to find it. Where is it? Here it is. All right, dip trace. If we open this in Explorer, fiddly dee, and open up the schematic. And we'll just try and recreate the same thing. So this is what I had in dip trace. So we've got some resistors, some LEDs, a connector, and a capacitor. So I guess we'll try that. Ooh, dearie me. How do I select something now? This, and then this, and then can you copy and paste it? You can. Okay, fine. Fine. And then let's say we want an LED. Yeah, you see, light emitting diode. Fine. Okay, fine. Footprint. Let's go with an 0603. Sure. Oh, how do you rotate it? Oh no. What's the keyboard shortcut for rotate? Is it R? It is. Okay, that wasn't totally hideous. Yeah, I suppose. Oh, oh no. Oh no. Okay. Selecty. Paste. This is the less glamorous side of this. Add a wire. Okay. Okay. What about a net port? Like voltage? No. Net. Let's look for ground, and oh, there it is. So okay, these are power symbols. Is there a way to see this in like a tree or something? Or are they, or it already is in a tree? Okay, P for power. No. How am I supposed to find things? How am I supposed to find things? Oh, I see. It's under device there, right. Power. Is it power? Power. It is. Okay. Let's say 5 volts. I mean, you don't need a footprint. I suppose. And then how do we do this? Oh, what happened there? There we go. Okay, so we've got some 5 volts. And oh look, there's a special one for just power. Oh, I didn't know that. Can we have a ground? Can we have a ground? There's a ground. Let's have it. I mean, in dip trace, we went like this. But, you know, arguably we shouldn't have done that. Okay, we're doing that. Let's save it. Okay. Then we need a capacitor. Capacitor. Unpolarized capacitor, I suppose. And then a footprint. We have 0402, sure. Why not? Oh, zooming. Okay. Sure, you know, this doesn't need to be the nicest schematic in the world. It just has to have some things on it that we need to lay out a PCB. Okay, fine. Save. So back to dip trace. And we add a connector. We need a connector. Let's add a connector. So this is going to be J. No. Let's see if we can find it in here. They're not very well categorized, are they? Like 4P2C. RJ connector as the first thing you look at. I think they could do better. Like within dip trace, for instance, they're all like properly organized. They're not in a tree view. Arguably, they should be in a tree view in here as well, but at least they're a little bit better organized. Anyway. So we got a 1x2 socket, I suppose. And then JST connectors, Molex connectors. It doesn't really matter really for what we want. We're gonna say yes, it does actually. Phoenix connector. I want header pins really. A pin header. Here we go. 2.54 vertical socket, and then you've got okay, fine. And then we'll take that. It's fine. And then we're going to need the 5 volts. What happens if you move this now? Oh, it does do it. Okay. Well, that's not totally hideous, is it? Okay, fine. We're going to copy that. And we're going to paste it. Sure. Right, we're nearly there. Sure. Okay, here we go. Now what? Yay, we've got schematic. It looks sort of like that, doesn't it? Okay, but one says 330, one says 470, and the other says 560. So let's do that. I have no idea how to do this. Cancel. See, in this, having the last tool selected for me is just weird. Like, that's not how my brain works. My brain sees something and it wants to click on it. But I have to go, no, I want to click on it, and then click on it, which I don't like. I don't like it. I don't like it. Okay, so I double-clicked it. We can put a value in. Let's do the same order. 330. Okay. 470. Let me use a cursor. What happens? Can I type? Yes, but how can I use the cursor to put focus here? Oh, F2. Never have guessed if I hadn't been using computers for 40 years that F2 is the magic key. Like, what's wrong with enter? Or, I don't know, enter probably. 470. Like, Like, if I do space on this, it toggles something, right? If I do enter, it goes down to the next one. But I can press cursor down to go to the next one. So why do you need two keys that go to the next one? And why? It's a bit weird. Okay, anyway. Next. I'm sure there's better ways of doing this. People can add their comments along with appropriate timestamps to help me learn this if they want. Let's have a look. 560. Sure. There we go. Amazing. Right. And then Mr. Capacitor, we haven't really got a value in this one. So let's say, well, we've actually got an actual part number in this one. Let's ignore that for now. It's fine. Okay, so we've got a schematic. Now what? I suppose we want a PCB editor. Did I click it? Oh no, I did. How do I link it with my schematic? Anybody know? I want to say, is it a netlist? Netlist file? I don't think I want a netlist file. I haven't made a netlist file. No. Board setup, maybe? No. It's probably really stupidly obvious somewhere, but clearly it's not obvious enough for me. Non-KiCad board? No. How'd you do it? I don't know. I haven't changed anything. I just created it. How do you make this be for that? Okay, let's try using the help. Yes, I suppose we'll use the online help. Online help. Here we go. Blah, 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 blah. Plugging, comment configuration, KiCad configuration project manager, creating a new project, importing, saving, and loading. No. None of these things. I don't need to do that. I created a project. Yes, I did that. Is it already linked to it? Maybe that's what my problem is. Maybe my understanding of the fact that you need to link it is wrong. Let's see. Oops. Is it already linked to the schematic? How do you place the components? Auto place footprint. Place offboard footprints. Is it here? Board edges must be defined on the edge cuts layer. So probably we need to draw a board. Don't know how to draw a board. Draw a rectangle. And then what? And then can you make this the board edge? Do we have to draw it on the right layer? How do you move the shape to a different layer? No, 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 don't know. Is it one of these? How do I know what layer I'm on? Layer. Edge cuts, it said. And then if I draw a rectangle on here, is that going to create a board outline for me? I don't know. Perhaps it did. And then what was that thing I found a minute ago? Auto place footprints. What did it do? Auto place footprints? No, you see, I don't think it's linked to it. I have no idea how to link to it. Board setup. So I've got a board. This isn't going well, is it? Okay, we're going to have to... I can create projects. I don't care about that. I don't care about configuration. I don't care about templates. I don't care about this. I don't care about that. No. Getting started, suppose, then. Circuit board. See, it's just not intuitive. Not intuitive. Right, we need a fan. Right. Navigation, blah blah blah. Board setup, don't care. What I care about is where the components comes from. Don't care about the constraints, don't care about net classes. Import and change from schematic. Here we go. Tools, update PCB from schematic, apparently. Oh, there it is. Okay. Sure. Now, what did that do? Oh, here's my components. Click. Right. How's hard work? So I've got a bunch of things. Are they selected there now? Yes. Oh dear. Oh dearie me. I just want to select it. There we go. And now I want to move it. Finally. Okay. See, in dip trace, you just grab it and move it, and you're done. Look. I don't know how anybody gets anything done in KiCad. It just seems unnecessary steps to actually doing something. This is what it feels like to me as an outsider to this. Like for me, in dip trace, I'm just like, you know, move it. Job done. You know, KiCad. No, you got to click, then you got to click again, and then you can move it. Why? Why can't I just click and drag it? You got to click, and then do it, right? So we got some net things, fine. Rotate, maybe? Yeah, okay, good. We're getting there. Oh, we're getting there. We're getting there now, people. This is all right. My ranting will come to an end soon. Okay. Yeah, new software, pain. It's, yeah. Learning a new bit of software, not fun. Is it in the middle? Yeah, something like that. Right. Because I don't know how to route traces in KiCad, I'm not even going to bother. In the dip trace thing, you know, we did this kind of thing, right? So I've got my LEDs and my resistors the other way around. Let's oh, multi-select. Okay. That didn't suck. Still the extra click is annoying though. Fine. So KiCad's got like the labels and the reference designators and stuff turned on. You can do it in dip trace by turning the things on. I've forgotten where it is now because I don't normally use them. Markings, yeah, here they are. And you can do it for everything. Somewhere. Yeah, component markings. Yeah, here we go. So you can do it on there as well. But we need to actually display them. I'm not going to bother. We don't care. Right, anyway, moving on. So we've got our thing and it's on a board. So we should be able to export a place receipt file, which is what we're actually interested in. Export. We've got fabrication outputs. Component placement, perhaps. It's not going to be the other ones. Output directory. Sure. Oh, where'd that go? Wait, what? Oh, there it is. This directory. But it did do CSV. I mean, the default was ASCII. I'm gonna say CSV since it gives us an option. Let's go single file as well. Right, and this hasn't got any concept of, well, at least I haven't seen it yet, of an assembly variant, but maybe there is somewhere else. But it has this do not populate flag, which is interesting. Like, we don't get any options as to which things are going to appear in the CSV file. Okay. Oh, and it called it a placement file as well. That was interesting. Okay, let's see what it created. Got to find the source. Here it is. Right. So, oh, I created it in the wrong directory. Nobody saw that, did they? Why? Okay. Like, why would you have this so you could scroll it and only see like half a line? Why wouldn't you have your scroll resolution so that it can't do that? No. one line at a time. It's log output. You know how big the lines are. You know what the resolution of the scroll bar should be. No. Room for improvement. Right. So let's delete that file and go back to here. So we've got this file. There we go. Let's compare it to the dip trace one. Let's compare it to the Let's compare it to the dip trace. No. Okay. IDE. Be like that. Split and move down. Okay. I don't know why it wouldn't let me drag it. Apparently this morning was better for me. This afternoon. Bit more hard work, it looks like. All right. Let's see. What do we note? Interestingly, the components refdes are in alphabetical order. So it appears both packages appear to have sorted their placements alphabetically by refdes. Okay. And then the column names. Right. Okay, so it's not used quotes everywhere. It's only used them when it didn't need to in KiCad. So the column name doesn't have double quotes, but the value does. But the value didn't need double quotes because there's no quotes in the name. So at some point, we're going to have to find out what happens if you put like single quotes and double quotes and commas and semicolons in all of these things to see how it goes completely pear-shaped with the CSV processor. I kind of want to do it now. Just let's have a look. Let's have a look. So we're going to close this. We're going to go back to C1. And then can we look at its properties somehow? What on earth is that? Footprint text properties? No. Okay. I mean, all this stuff is fine. No, I'm not really expecting to be able to change it in there, to be honest. I think we need to go back to Mr. Schematic and let's edit this. Okay, let's put a double quotes in there. And let's say TBD. You know, arguably someone could do that, right? Okay, and then we're going to go Tools, Update PCB from Schematic. Change C1 value from C to TBD. And interestingly, it doesn't put single quotes around these things, which it probably should do, so you can see whether there's trailing spaces and things like that in there. But what do I know about software, you know? Update, close. Right, so we've got this in here. So now let's export or create the fabrication thing or create this. Okay, it keeps the same settings. That's useful. Generate position file. Go. And now let's go back to Mr. IDE. Yeah, right. Okay, fine. Whatever. We know what it looks like now. Yeah, kind of what I expected to see there. And this is why your CSV parsers need to be not rubbish. Because if you were just doing the naive way of reading a line input and then splitting it on comma and then removing, I don't know, looking for quotes and looking for an end quotes and all that kind of thing, it might not work so well. Splitting it by commas and then removing any surrounding quotes might be an approach that works. But here we are. Right. What else can we see in here? This is interesting. The amount of decimal places that you have. Curious. Okay. And it's got top like this. And then it's got, this is the rotation. What we're going to need to do at some point, not today, is to go, okay, well, how is a footprint defined? Right? And you just display the footprint as it is in the library. Then place that footprint in the same orientation that it is in the library on your PCB, and then export it. And then take a copy of that footprint, put it next to it, and rotate it clockwise 90 degrees, and then export it again, and then look to see which direction it is. Because it could be positive rotation or it could be negative rotation. And we're going to need to see whether these two tools are the same in that regard. And then we're going to also need to try and rotate it more than 360 degrees. Well, or exactly 360 degrees. And then also rotate it the other way to see if the rotation wraps around or whether it's truncated between a certain range or things like that. Because you need to have handling in the tool that we're building in order to unwrap it and normalize it and make it consistent between all the packages. But not today, but we're going to have to do all that. Okay, so we've got basically val and a package, whereas diptrace has got name, a pattern, and a value. Let's see. Well, we didn't get any options, did we, to say what we want to be output in KiCad? We didn't get any options. So can we have a look at one of these things? So this is we've got a value, which is the TBD, and then we've got a package, which is what? Can you change it? No. Oh, there's a change footprint there. Oh, I see. So then you can pick a new one. Oh. Let's just quickly change it to like 0603 or something, see what happens. And then do we go change or save? Save or change? What's change going to do? What's save going to do? Oh, it generates a report. Well, why is it not called report ... Is it because it thinks I know that this save button is related to the output messages? Oh, it is, because there is a little grey box there. Okay. Okay, fine. I'll let it off. Fine. Change. What? Perhaps this should be disabled until you've actually clicked change. That might make it more useful, right? Because there's nothing to save, was there? There wasn't anything to save. Anyway, right. So we've changed things. And then we're going to go close. Fine. Save. And then let's go export. No. Fab outputs. This. Okay. Maybe at some point I'm going to do some work on KiCad to make it more nice to use. What are we doing? This. Here we go. So now does it say 0603 there? Yeah, it does. Okay, so this is just the package name. Right. What happens if you add an extra field? Whatever something. No, this one. Now we're on CSV. Yes, it's got this save thing here. Yeah, it should just be disabled until there's something to save, shouldn't it? Why would you not? Maybe I don't know. Maybe there's some history that I don't know about. Doesn't seem right to me though. What did I just do? Oh, we added an extra field. So the extra field doesn't appear in the output. Okay. With dip trace, when you export things, you get the option to say what things you want in it. And you can pick like random fields. You can just go whatever, and then you can go custom field that's on whatever it is, you know, and it'll end up in the CSV file. Which is arguably nicer. Right. Anyway. So we're still trying to make head or tail of this. So we've got a val and a package. Because in dip trace, you've got pattern. And a pattern it describes both the footprint, and along with the footprint, there is a 3D model associated with it. And the 3D model is actually the package. They don't really differentiate having a package and a pattern separately. Arguably, they all should. Because any number of packages can fit on a given footprint, right? Am I the only person that sees this? I don't know. Sometimes I think I'm so special. Can't be the only person that sees this. Right. Okay. Let's make it happen. This is what we've got. This is what we've got now. What kind of test do we need for this? What kind of test do we need? Well, let's look at the let's look at some code. Here we go then. Right. Let's put this. See, I can put it back there. Why can't I take it out? Why? Look. Why? It's not working. Anyway. Not working. Oh, well, at least I can submit a bug report for the Rust Rover people and say, oi, go back to this stream, look at time index, whatever, and you'll see the problem. Not making it up. Right. What are we doing? So we've got our command, right? And we've got a bunch of arguments for it. This is what I'm trying to get to. Right, and one of them is the source for the placements. Okay, let's look at the file names that were generated by default. So when we exported something from diptrace, it goes like this. Look, you go export, pick and place, and you go export to file, and you can type in whatever you want, and then it just adds .csv to the end of it. Right, KiCad didn't do that. KiCad was different. KiCad, you go file, fab output, puts, component placement. You give it directory, right? And then what it did, it created some files with a suffix and -pos.csv. Okay. Let's pick one of the other options just so that we can get some more visibility on what it actually does. Separate files to front or back, generate, off you go. So we've got top and bottom now, all top and bottom. Right, and then there shouldn't be anything in this one. Fine. Right. So that's what KiCad generates. But it's still, at the end of the day, is just a .csv file. Right. Fine. Okay. So the placements arg is the one that we've got to deal with. Because right now we give it a file name. Now, when I started this, when we were dealing with this stuff, let me just refresh you guys' memory. In the variant builder bin file, where we've got the command to get the placements. Now, I wrote the word file here, but I know that there's more things to life than just files. And then what we did, where we used this placements thing, we say build assembly variants and we give it placements. And I was careful not to name this placements file here. Here, I called it placement source. So my thought, well, there's a couple of ways we could do this. There's a few different ways. We could add another argument to say what the EDA tool is as a hint, right? And arguably, the placement source could be a URL which could contain file : / some system path, whatever. Or it could be, I don't know, any kind of URL that you can imagine. Right. Could be an IP address for all I care. But that doesn't really help the tool understand what it's trying to connect to unless the URL is a very specific URL. Which in the case of a CSV file living on an HTTP server, it still wouldn't know. So I think probably what we need is like an EDA arg to say we're dealing with a dip trace or we're dealing with KiCad. So let's break some things. So build. dash EDA dip trace. Sure. Why not? Right, that will cause a test to break, won't it? Yeah. It'll go, what the hell's this argument? I don't know. I don't know. I don't know, lad. I don't know. Yeah. What am I doing here? Yeah, I'm trying to find my tests, but I'm clicking the wrong thing. Here we go. That's what we need. Right, so this should break stuff. It's going to go, what's this? Don't know what it is. Okay, and our help doesn't have the EDA thing either. Let's just say what we want in here. EDA equals, and I don't know what it's supposed to look like. Should it be something like that? Let's see if we can make it use a short list of things. EDA tool. I don't really want to say format here, because within a given for a given tool. Oh well, maybe. Because each tool can export things in a different format, you see, but you still need to know what tool it is, so that when you come to look at the format, you've got a hope in hell's chance of understanding it. I suppose if there was different versions of the format and so on, things could be intelligent, or we could provide it other hints for whatever it is that we're trying to get it to load. So let's not deal with that to start with. Let's just go with EDA tool and then whatever it is, right? And then hopefully we can use this information appropriately in the tool. EDA tool. Sure. No. More actions. Add to dictionary. Why was KiCad in there? What? Favoritism? Maybe I added it before, I don't know. Okay. Diddly do. So we're gonna add it here. We're gonna go EDA, and it's gonna be EDA tool. Sure. And it needs to have this comment. Plop, like that, right? And then we need to define this EDA tool thing. Let's have a think about this. We've got an EDA package with a mod in it. It feels like we could go enum, EDA tool, dip trace, KiCad, right? And then input, and then make it public, and then import it, and then hope that we can do some sort of like deserialization from an enum into it or something. It might be that we want to specify an arg, because really this is an arg, isn't it? And it's sort of command line tool specific stuff. Let's we'll leave it like that for now, but I might revisit that. Okay, now let's see what happens. Bone is not satisfied. Yeah, you know. Yeah, I think I'm right. So we've got this, and this is our sort of like domain thing, internal thing, and then we've got stuff to do with command line stuff, and that's going to go in here somewhere. It's going to be a copy of this, and it's going to be an arg. And this is going to have the config loan on it. Not config. Derive. Told you it's a bit of a struggle today, didn't I? Okay. Right. So yeah. Pattern does not mention EDA. Yeah, that's okay. So we need to do something to this enum to make it so that clap can understand it. Value enum, look. So let's have a look at the clap documentation. Let's curious. Yeah, okay. It'll be in the clap documentation. Let's look at the clap documentation using a web browser. Clap Rust enum. Wait. Derive. No, clap. Here we go. Right. Let's look at the documentation. Args. Parser. Arg. Struct. Enum. Here we go. We've got command. Here. That's what we want. Look, we want this. I think that's what we want anyway. If it turns out not to be true, then we'll come back and read the documentation a bit more. Go. Okay, great. It did something. The missing field. Right, so we've got that. Use variable, that's perfect. I'll use import. Yeah, we don't do this yet. Let me think about that. So we've got, yeah, right. So EDA, right? We've got this EDA tool arg. And here we pass an EDA tool arg to this, but I think probably where to do the conversion. Yeah. This is one of those curious cases where you probably could actually use from and so on, because it'll be non-destructive mostly, I think. I don't know. It's build something. We'll call it build for now. And this is going to return an EDA tool. And this is obviously just going to be stupidly done. Oh, match self, sorry. Oops, daisy. So if it's one of these, then you get... I know, it feels dumb, right? Doing this. But trust me, someone at some point in the future will come back to this and go, oh, I'm glad you made that separation there. Thanks. Or it might not. Right, okay, fine. So we can, we've got our stupid little thing like this. Yeah, fine. So, and currently it can't fail. In the future, it might be able to fail. It might want to show a warning if you try and use it to say it's deprecated. Who knows what we're going to need to do? But now we can do it, and we can do this build thing, and it's fine. Right. So let's run all the tests. 10 were supplied. Right. And then we've got this EDA tool thing here, and if we add this on the end, and then say add it as the 10th, and then do the refactory thing where we change the refact introduce, blah, 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 change method signature. There it is. I can't see it for looking. EDA tool. Yes, I know there's a lot of things on this method. Refactor. There we go. Right. So build assembly variant. Now it takes an EDA tool, which is an EDA tool as opposed to an EDA tool argument. So EDA tool doesn't implement debug. Well, it will soon. Sure. Well, yes. Probably because someone wants to print it out. Yeah. Oh, it's because of the tracing stuff. It's because of the tracing stuff. So it needs to be everywhere. Yeah. Okay, let's run it again. Fine. So let's have a look at the help now. The help says, well, hey, why does it? Okay, that's interesting. Oh, I guess it's not an option, is it then? You have to specify, don't you? Okay, fine. Oh, look, it's done that. Okay, sure. This is how it wants it. This is how it's going to be. No. Right. And it's got this here. Like, why is that not like at the start? Like here, I put it at the start, but it's put it here. Oh, I haven't got an arg thing on there. Okay, let's see what happens now. There we go. That's what I wanted. That's better, isn't it? That's what I wanted. Yeah. Where's this hyphen coming from? Is it? Oh, it's because I put a capital C in the arg, no? Yeah, I did. Let's just see if that's right, because dip trace hasn't got a capital T there, and I don't really want to go dip dash trace. Let's see how the KiCad people talk about KiCad on their website. They use a capital C. And the dip trace people say, okay, fine. And this is why you do separation. Ta-da! So really, this thing should have one of those clap argument things on it. Let's see. Because it says you can have value and then whatever, right? So this then needs to be like KiCad. And then this needs to be, and if we're going to be, have the enum variants separated with the letters in the same way that the authors of their respective programs do, then we can say, this, right? Possibly, we need to review some other cases where we've used enums and be consistent. Yeah. Okay, let's run all the tests. Dip trace requires a value. What? Oh, oops. Dip trace requires. Why is it not complaining about the KiCad one? Maybe I'm misunderstanding this. Possible value. Oh, I see. This isn't. No. I think this is supposed to be like name or something. We'll have a look properly in a minute, but let's just see if my guess is right. No. Okay. You never know. Sometimes you get lucky. Derive. Value enum. Here it is. Oh, it's rename, isn't it? Oh, look, it's got rename all lowercase. I mean, we could do that on the thing itself. There's a tutorial. Okay. Validated values. Arg parser, yeah, not that. Arg value parser, no. I've done value parsing before. It's not that. Argument relations. No. No. Where's that? I want some enums. Come on. Show me the enums. Nope. That was no good. Enumerated values. No. Okay, go away. So you can have an alias of something. Let's try that. Let's try this. So. Here you go. Okay, compilation success. That's good. Help the build command. Now it says dip dash trace or no. We've got alias, you see. No. Can you just do rename on it? Let's have a look. Right. I guess having an alias with a dash in it might be useful. Value enum attribute. So it's got name. See. Oh, this is command attributes. Fields. I want a arg attributes. ID. When not present. Okay. Arg attributes? Arg? I mean, is this really an arg? No. Value enum attributes. This is what we want to be doing. Name equals whatever. I thought that's what I did. Maybe I didn't have it right. Name. Maybe it's supposed to be like this. No. Magic attributes. Raw attributes. Value. We've got alias. We've got help. We've got skip. What is a magic attribute? Terminology for syntax. Arg. Is it arg? Name? Thing? Just one example would be nice. Expected value instead of arg. So maybe you go value name and then whatever. Oh, you see, how are you supposed to guess that? How are you supposed to know? How are you supposed to work that out from this documentation? I mean, am I missing something here? Magic. It's not magic. It's a way of describing what it is. This is not a good way of describing it. Magic. What's magic about that? Nothing. See, and then you've got value and you've got alias here, but then alias isn't listed in the magic attributes. All right. These correspond to a possible value. Right, but this is using the builder and not the derive syntax, so it's a little bit tricky. Yeah, you know. Some days it just makes you wonder whether you should be using the derived stuff with this clap thing, or just because the documentation is not clear. Not clear at all. Right. Possible that I just don't want to read thousands of lines of documentation. I just want to have it work. But there we are. Right. So where do we get to? So now we've got this probably, which we need to add, I imagine, into our thing test. Right. But that's not right now because we need that. Okay. So cool. So the build still works, and we're passing it a dip trace file, which is good. So there's nothing really to do until we try and give it a KiCad file, right? And then it's going to go very wrong. How are we going to do this? How are we going to do this without creating way too much duplication and so on? Right. Because we could, you know, what options have we got here? We've got this variant builder test. This one with all this stuff in it, right? Create this, create that, map this to that, yada yada yada. Maybe it's useful to do it. Maybe it's useful to do it, but this is where the test is, right? This test is like testing a lot of stuff. Arguably, it's testing way too much. And often, only when you come to add another test that needs to test some of the same things do you realize it's unwieldy. Because some of the things that we need to test are the same. So we've got this generation of a tree, but we're not going to have name and value. We're going to have KiCad specific things, which is going to be val and package. Possibly. Perhaps. Don't know. Yeah. Yeah. Okay. What does KiCad actually mean by package? I want to know that at some point. Let me write that down because that might be something I'll forget. Let's have a look. What does KiCad mean by like footprint, pattern, package, all? Because in the pick and place software that we're going to write at some point, you know, once we get done with this workflow stuff, we need to define a footprint and a package separately. It's very important for a pick and place machine because a pick and place machine sees the package from the top with the top camera, it can see the footprint on the PCB, and it can see the package from the bottom using the bottom camera. So these things need to be well defined in the pick and place machine software and not smushed together like they are in some of the EDA pick and place machine export files that we've currently got. Righto. So I think we should just start off with simple functional test, which gives it a KiCad placement CSV file and just does some basic mapping like we started off with the dip trace one. And we'll see whether we need to do the whole rule resolution stuff again like we did with the dip trace one or not. Probably we're going to have to deal with some substitutions and some part mappings, right? But we probably don't need to deal with like an assembly variant and some of the other things like that, because they're the same in both. Okay, so let's start with that. Okay, so this is our basic test here. Let's create a new test called, I don't know, pub run KiCad 1. When, and then some of this is going to be the same. When we run a command with some args, it should do some stuff. All right. This bit's going to be very similar. Okay. When we run the command with some args, then we want to assert, and we want to print the things, and it should be successful. Yeah. Right. We want to build, and the EDA thing needs to be KiCad now. Cool. It's going to need replacements. It's going to need parts. It's going to need mappings. We don't need loadout. We don't need substitutions yet. We don't need assembly rules yet. We need a CSV output argument. We don't care about any assembly variants right now, or disabling some refdeses. That's what we're going to begin with. Okay, cool. So this command is defined like so up here, and we're going to need this temp directory. We're going to need some placements, and yeah, let's create a placements file first. So we'll steal the dip trace one. Let's split and move right. Did I not? Split right. Okay, fine. So we've got the dip trace one up here, which we can refer to, and then we're going to have the new KiCad one down here. Ooh, exciting. Paste. That's what we're doing. And then let's delete all of these ones, except for the first one. Plop. This is the same, this is the same, this is the same, this is the same, and this is the same. Fine. But no, not the same. So for a KiCad placement record, yeah, we need to change some of the T's in the dip trace thing to a capital T. KiCad placement record, they have a refdes. Here we go. Now we can see. They have a refdes, but it's called ref. really. And ref is a reserved word in Rust. We've got to do aliasing and all this kind of malarkey now. Fine. Okay, and then we've got val and package. So val is the same as like value. So we'll leave that there it is. And then we're going to have package like this. And the package really is sort of the footprint thing. And we're going to use like KiCad sort of like example things, just like we did for the dip trace ones, right? When I created this, the R was on those resistors, and for some reason I put the numbers after the R instead of in front of it, which I think was a mistake. Let's go back to my schematic. Like, what do other people do? Because normally you write it like this, right? Oh dear. See, I'm trying to double click it. Oh, there it goes. See the return, like either return to edit it or return to close the dialog, please. Not return to go down a line. Whose idea was that? Let's save. Update from the schematic. Here we go. Tools, update PCB from schematic. Yes, update. Okay. Save, file, fab, base components. Single file, generate, close. Save. Again, perhaps. Don't know. Right. And now they're this way around. Fine. So where we've got our dip trace placement ones, right? We can take the same thing and slap in a KiCad one. Right. But we have to deal with this. I don't know how you're supposed to do it. We'll find out. And then we need a package and val. Okay. Yeah, we'll come back to that because it's probably wrong. So we've written a placement record. Yay. But we need this arg thing. We need an arg. Arg. Pyrotastic. I'm going to delete this and. I deleted the and for the other ones. This is all placement stuff, basically. So we've got placements arg. Great. Placements file name, yada, yada, yada. Now, because KiCad's KiCad, and it added some extra things on the end of the file name, our test is going to be somewhat representative of a real-world situation. And our file was all-pos. So we're going to do the same thing there. Right, righty-ho. And then we're going to need some global substitutions. Because, oh, we need some parts. Oh, we are going to need substitutions. No, we don't. No, we don't. No, we don't. No, we don't. No, we just need the part mappings. Okay, fine. We don't need loadouts. Parts. Here we go. Let's create some parts in the same way we did. Paste. Delete. Right, this is the same thing because this is not in EDA land anymore. It's in happy MakerPnP land. Okay, I deleted the wrong one. Okay, so we've got our part, and this one is going to be that one in the same way that it was in the other test. And we've got our parts arc now, right? But now we need the parts mappings. So we're going to create parts mappings same way. And we're going to need our arg and our flush. File. And this isn't dip trace over here anymore. This is going to be KiCad. And it's going to match when the package is this. And the value is this. No, we're going to need our substitutions. We're going to need our substitutions. Yeah, and our part mappings, it's all not happy times. Yeah. Right. Because our part mapping records aren't EDA tool specific. Because they have this name and value thing. Yeah. Es muy complicado. Okay. We'll come back to that in a moment. Let's try and make that the only compilation failure that we're going to have. Yeah. We are going to build a CSV file for it. I don't really want to assert the CSV just yet. We will do. Not just yet. And we're going to do the trace logging as well. Right. So this should all sort of compile apart from this. This is our sticking point right now. So let's have a look at one of the test part mappings over here. So it feels like it feels like we need this sort of details thing that gets flattened into it when it's red somehow. Either that or our part mapping records We need different ones for each of it. Let's This is tricky. This is tricky. I'm just going to write these down so that we can see what we've got. Oh, hi, people in the chat. Format makes sense. Yeah, I mean, yeah, I was looking at the rename all lower thing, but I specifically didn't want to put that on there because I don't know whether that's going to be the same for every single package thing that we have in future, because there might be Altium Designer and they might use a lowercase d, for instance, when they refer to it. So I didn't want to do the rename all thing. I wanted to be more explicit with the renaming. Hi, eat lemon. I've got a lemon tree. I was looking after it yesterday. I was out in my garden, and we get these cochinillas, they're called in Spain, and they're like all over my lemon tree, like sucking life out of it. They are. So I had to get my spray out, and I was doing that. My lemon tree had a bunch of flowers on it, but currently it's only got one lemon growing on it, and it's about this big so far. Last year, the one that came out of it was like this. I had about 2 or 3 last year, about this big. Since I moved into this house, I've been trying to rescue this lemon tree, but it's not a happy bunny. The other plants are like stealing its water, and I had to chop the roots out and everything. Still, there we are. Lemon tree. Eat lemon. Will do. Check. Let's just write package here like this. And val. Now, and then let's say from to. Just so that it's sort of visually split up a little bit. Now, I don't know whether that's what we want. I don't know whether that's what we want right now. What I want to look at is how we go from a part mapping record in the code into something, because I think we had this concept of details in the production code, but in the test code it doesn't have any of that. And I only wrote it a couple of days ago, and I can't remember. How am I supposed to remember? Too much code to remember. CSV. Let's have a look. What happened to that? There it is. Part record. Part mapping record. Here we go. Part mapping record. So in our production code, we've got it like this so that we can differentiate between the two different types when we deserialize it, which is good. Wait. When do we use this and when do we use this? I don't remember. Part mapping record. Let's see when we use this. Because we go try from a part mapping record, and then it tries to go through all the different types of ones to find one that it can create. Which seems like it's okay. Right? You guys saw that, right? We go try from, and then we look at the thing and go, if it's dip trace, then do this. But we've got our own implementation of this because we decided that Serde was not really the best thing for the job when it comes to serializing and deserializing CSV files. Now it could be, and I was thinking about this yesterday, that my first thought about using CSV files for all these data files that we need to define that don't come from the EDA tools, I thought using CSV files for those is probably a good idea. I'm not 100% sure that is correct. Now, I initially thought that because, right, yes, thanks, Corsair. Because we bring up the exemplar. Yeah. Because, you know, I was doing the same kind of thing before in Excel and whatever. It's not Excel, it's Google Docs and whatever. So to find part mappings like this, which is fine unless you need to get complicated like we do now. I think what we're going to have to do I don't know, what are we going to have to do? Hold on. Dip trace part mapping. Yeah, okay. Yeah, I think where I was going with this is it's probably workable. It's not ideal. But it sort of makes some sense. So I don't know what happens if you try and serialize something that's optional. But we're going to find out. Now, will this break the other test? That's what I want to know. Because when we try and serialize this, these are going to be none. Now, implementing defaults so that we can use the ... remaining fields thing. We're going to have some fun in a moment. Here we go. Right. So now we create this and we can say sum or whatever. And we're going to use the KiCad named things. Test part mapper record. Now this is complaining because we haven't got the dip trace name and value ones in here, right? So in Rust, what you can do is go ... Right? Something like this. Something like this. I forget the syntax. It's not something I do very often. Let's go Rust default field struct. No, the documentation, please. I mean, there is ... default, whatever. This is it. Yeah. Let's see, because I'm not familiar with this. Dip trace. Let's go KiCad. Let's see if we can do this. I've never done this before. Test. Let's delete that. Go back. Test. Art mapping record. KiCad defaults. Perhaps. Why can't I create this function? Like, doesn't. No. Why? That's weird. Like, the IDE was failing me there. And it's got to give us a test part mapping record back with some stuff in it. I suppose if we're going to do that, we could put that in here, right? That might make it a bit nicer for the rest of the tests that we're going to write. And then we know that the name needs to be provided. Currently isn't optional. At some point, we'll try and make this optional in a bit, and we're going to see how far we get with this. And then what we could do is go default like this, perhaps. I don't know whether we can chain them like this. Let's find out. And then I suppose we need these back. And then we're going to have the package as none and the val as none. And then the manufacturers. Woe betide anybody that actually creates one with a empty manufacturer and part name thing. I don't know, you can have a validate method somewhere else. I'm not sure if that's the remit of this. What we're going to do now is just trying to fill in all the blanks. So I suppose we need to take that off there, right? And then we got this. Base expression required after ... Isn't that what we're doing? What's the difference between that and this? Didn't we have a... What happened to my search thing? I don't know. Rust default this thing. People said default, and then... Right. And then someone else said you can do whatever, like this. Oh, I see. Is that how you have to do it? It might be. I'm not sure whether that's right. No. How'd you do it? How'd you do it? I know we can go default, right? Oh, we can't. Apparently, it doesn't like that either. Well, that's unexpected. Why doesn't it like this? Base expression required after dot dot. What does that mean? What is a? Let's get rid of this for now. What is it? What does it mean? Base expression after whatever. Is it just the IDE being stupid? It might be, you know. Because there wasn't an error here, was there? Okay, well let's deal with the old test. And let's deal with this the same way. Right? Which means we can delete this and we can go part mapping record, dip trace defaults. See, it's not. I think it's just the IDE being dumb. Look, because this one isn't highlighting as being a problem, and it's throwing me off. Sure. Control backspace? No. Control shift backspace? No. Control shift del? No. Control shift what? No. Okay. I want to know the keyboard shortcut for deleting a line. Fine. Whatever. You see Control Y. I mean, then what's redo going to be? Let's go delete line like this, and then let's look up in the settings now. Is redo going to be Control Shift Z? Yes. Fine, I will live with that. No. Yes. No. Yes. And then in the end, I don't even do it like that anyway. Never mind. Yes. Okay, fine. So what about now? Question mark can only be used in a function that returns some stuff. Okay, fine. So bring up the structure. Build this one. And go away structure. Go away thing. this signature needs to be that. But KiCad, build KiCad. That might be a little bit better. We need a thingy. There we go. Right. Go. Mismatch types. Oh yeah. And we have to, at the end of this, if everything is fine, we have to say yes. Okay. That's interesting. It actually compiled, but does it run? Because the optional things in the record. The production code is going to now see 2 extra fields that it doesn't use. But it does indeed work. That's good. That's excellent. Okay. So now we can go back to the dip trace part recordy thingies and see if we can change these to options. Right. Which is going to obviously be complainy. Okay, let me undo that. Because we can be more clever. Part mapping record, part mapping record, part mapping record, part undo. Then go some stuff, right? And then we can go down, home, control clicky, some whatever, right? Oh, what happened here? What's wrong with this? I don't know. Can't see it. Well, yeah, I mean, now we can say none here, which is much better. Okay, cool. So I don't know why the IDE is complaining, but it is complaining nonetheless. Yeah, and we didn't pass over the trace argument. Trace log argument, this. Yeah, we need that in here. I didn't uncomment it, right. Fine, that's better. Now, these 2 paths we're not using because we're not asserting anything yet, but we will do. So, where does that take? Where does that give us? What does that give us? It goes missing field name. When we're trying to load placements here. That's interesting. Oh, placement. Placement. EDA placement. Let's have a look at our EDA placement. I was thinking part mapping for some reason. Do the EDA placement. So we basically try to build one of these with some details in it. And yeah, right. Right, so we need the same approach with the placements that we do with the part mappings, where we have to know about the tool that's being used in order to do something appropriate. Now, we're not going to look in. We're not going to look at the CSV file that we've been given. We're going to look at the argument that we passed over on the command line. So load EDA placements needs to be given the tool. So this needs to be given the tool. Thus. Oh, you can do it by putting it in there. Fine. So we've got EDA tool now. Great. So now I suppose we can go something else. Let's refer to the part mapping thingamajigamy. Let's get rid of this. We don't need that anymore. Where we load the part mappings. The part mappings, it goes CSV part mapping record, which has got any number of fields in it, and then we do this try from thing, and then we create a record which has got the details in it. Okay, and then let's look at the placement again for a moment. EDA placement, and this, has got the details in it. So it's the same kind of thing, right? The same kind of thing. Okay, yeah, that seems reasonable. So we'll transition this to use the same approach. So we've got a CSV part mapping record. So instead of a dip trace placement record, we're going to need a CSV. Well, are we? No. No. It's not the same, is it? No, it's not the same. We're going to go. We're going to do something else. Let's do it the simple, naive way to start with, and then go from there. We're going to go match EDA tool. And if the EDA tool is dip traced, then we're going to do all of the things that we were doing before. Right? And now, if the EDA tool is KiCad, then we're going to do all the same stuff, but with different things. It's going to be a KiCad placement. KiCad placement record. Right. And then we'll come back and refactor this in a bit. Dip trace placement record lives in dip trace. So no, new. We need a mod. We need a KiCad. Seems reasonable. Let's create it. Yes, like that. And we're going to need a CSV mod as well. Mod CSV. Sure. Inside here. And then here we've got this dip trace placement record, and we want one of these things in here. But instead of it being a dip trace one, it's going to be a KiCad one, and it's going to have refdes, package, and value. But we need to rename this thing. Let's look at the Survey documentation for a moment, because we're going to have to deal with this. Because we need to put something here. Okay, so survey Rust rename field attributes. Yeah, that's what we want. Rename like this. Yeah. When we're deserializing it, we say that it's ref. Right, and then when we're serializing it in our test, which was here, we can now go back in and put the same thing in here, right? Right? Seems about right. Right, where do we get to? So we've got that, we've got this, we've got that, we've got that, we've got this, blah, 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 blah. I'm going back, trying to find where we were. There, this is where we were. So now we can import this. Why is it complaining about that? Why does it think... Oh, this CSV reader is trying to... I don't know what it's going to do right now. It seems a bit weird. Yeah, incompatible types. Why does it think this reader is going to create dip trace placement records when it's not? Hmm. This deserialize method says it's supposed to deserialize records into a type of record, right? So it thinks that the type of the record is the same as one of these things that might first one of these that's used, right? Because it comes from this. So we might have to do something else here. Like creating your own deserializer and then using the right deserializer. Oh, well, it's just got more complicated. I mean, potentially we could create an intermediate thing. But I don't want to. At least I don't think I want to. Yeah, CSV reader. think we don't do that. Let's say line in CSV reader dot but then there's headers. You've got to deal with headers. Okay, we're going to go CSV reader dot headers. And we're going to say get the headers. We don't care about the headers. Yeah, but we do see, because the things could be in different orders in the file. And it's going to be a nightmare. No. We need the intermediate object. No, if we're using Surday, we're going to use Surday. It's fine. Right. So, yeah, no. Whatever. I don't like this. I don't like it. Because we said, we've got this thing, we've got this. Don't care about the header. Don't care about this. No. No. I'm not doing it. I'm not doing it. Not doing it that way. It's just wrong. Okay, let's keep that as the dip trace bit. I think perhaps we were on the right track, but not quite. I think perhaps we need to go match EDA tool outside the loop, dip trace, and then the type of the result will be correct for the thing that is now in here, because it's a sort of generics problem, you see, right? We were close, but no. Perhaps we can make a function, a generic function for this in a moment. But now, when we change this to KiCad placement record, the type of this result in the loop is correct. So this is sort of generic over t, where t is whatever it is. So we could extract that to a function in a bit. Okay, this is great. So we've got this build EDA placement, and it does all this stuff for the dip trace one, and we're going to need the same stuff for the KiCad one. Where was that? This is in diptrace CSV. Fine. Plop. And then we're going to do the comment out malarkey. And apparently this can return errors. So apparently we need some errors as well. Seems reasonable. And then we can put this back. And import this. And then we can, do all this stuff. So place is going to be true by default. Ref des is going to be the same. The details, however, are not going to be diptrace ones. They're going to be KiCad ones. We don't have that yet. We do have that. We don't have these things yet. We know what we're going to put in them. It's going to be package and val, right? Here's one we made earlier. Package and val, we said, right? Sure. Oh. It does help if you put the function in an import block, doesn't it? No one saw that, right? But we don't have package here. We've got package. And this value should not be value. It should be val. And I probably renamed that the wrong way, so there's probably going to be another compiler error now. Right. Excellent. Now we're on to the non-exhaustive pattern matching stuff. Right. So if you want to match a dip trace placement mapping to something, you need to look at the name and the value. But if you're doing a KiCad one, you need to look at other things, and this is going to be wrong. And I can already see there being problems because exact match criteria here isn't a dip trace specific one. And I knew this was going to happen when I wrote this. Because there's no corresponding things for name and value for KiCad, right? Let's see where exact match criteria is used. Many places. Let's see. This is all dip trace specific stuff. Because there's a couple of ways of doing this exact match thing, but then it might not be an exact match thing anyway. See, it's like, We could go very specific or we could go very generic. I think these are our two options. Very specific is to provide exact match things, one for each type of EDA tool that we're using. very generic is then probably not going to be an exact match thing if you specify the fields that you want to use and the values that you should match on those fields. So for instance, you could have a hash map of fields with a name and a value for it for each one. Which might not be totally hideous, actually, now that I'm thinking about it. But it wouldn't be an exact match then, would it? It would be like a field match. Maybe if we changed all the code to use a field match, it wouldn't be so bad either, because an exact match isn't really that useful anyway. And I guess it's more of an exact field match as opposed to an exact regular expression field match thing. Well, you know, we've got the tests for it. Let's see if we can get it to a point where it can compile so that we can refactor this exact match criteria thing. So we can have a bunch of to-dos in here because they compile, right? And we can repeat this until it compiles. Don't know what it is that I'm typing in right now, but I don't really care. We're going to find all the to-dos eventually. To-do. Oh, 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 look. Okay, fine. Well, we know this is going to fail because, well, unknown EDA KiCad with double quotes. Okay, let me work out where that's coming from. Part mappings, CSV mod, part mapping record, unknown EDA, and then we've got this. This is used by this, and we've got dip trace. Okay, let's carry on with this a little bit, and then we'll come back to the other to-do things. So if it says, yeah, okay. If it says KiCad, then create a KiCad part mapping, which we don't have in here yet. We know we're going to need to futz around with those criterias, but let's unbreak some of the other stuff. And then we'll just keep running the test until all the to-dos are done. Right? So we'll just keep going through one thing at a time. KiCad part mapping record. So we've got this dip trace part mapping record, which looks like this. And a KiCad part mapping record looks like package and val goes to these things, right? That's what we said we're going to write. Okay, off you go. Right. Oops, wrong one. Yeah. Package val. But this value thing here is a CSV part mapping record, which can have option string now, because this is what we said in our test. And maybe we use Serde slightly differently in the future and create an enum instead of these things and use it, but this will do for now. Right, so now we can get package out of this and val out of this. Right. Yeah, you see, yeah, this is a bit funky. Because there's a couple of ways of doing this. We can call unwrap on these things and hope that everything's fine. Or we could have better error handling. By checking things in like up here, you can have like a tuple struct where you pass in where it extracts the sum, whatever, and then if it's then you could go if whatever, and the other thing is a sum, then you can undo it, and if you can't do it, then you don't even try to call unwrap, and then you just give an error. But probably these need to go into like some more Serde thing with the enum, and it's probably going to be better that way at some point. But red green refactor, get it working, but then get it working well. Right, non-exhaustive. Oh dear no. So what is this? Can we write this code? We can go OK with the part where the manufacturer is the R dot. Yeah, we can write this. Yeah. Is it the IDE being funky again? I think it is. I think it's just missing brackets. Oh, I've got an R. Got an E there. I typoed. Okay, fine. Right, and then what we're doing here, we are building part mappings. Yeah, and this is another bit of the criteria where we can't build it properly. This is going to have to be a to-do, I think, because in the record we have this and package, but in the exact match criteria we don't have the corresponding names. So that's okay. Yeah, it's fine. Okay, let's run this. The other one still runs. That's good. Not yet implemented. Right. So we're trying to build a part mapping. Trying to build a part mapping. Trying to build the criteria. So we're onto the criteria thing now. Okay, let's see if we can compile the other tests. Oh, surprisingly, we can, and they all pass. That's good. Yeah. And then this is where we're going to need to futz around with stuff, this criteria stuff, right? But I think we're gonna call a time on it here on this stream because it's getting on a bit. It's about 8:30 or so here. I need some food. I think we've made good progress and we've got a failing test. So tomorrow I shall continue with the failing test and write some more code to refactor all this criteria stuff. Not sure what I'm going to do with it yet. I think I like the idea. I'm going to make a note before I forget. To do or consider using a hash map of fields and values so it can work for any type of placement. I mean, currently this criteria thing is living in dip trace criteria. I mean, do we do that? Do we do that? Or do we just like move the criteria stuff out of the dip trace thing so that it's just generic criteria? It's probably going to be more useful and reusable if we do that. Um, then move outside of the Pip trace package. Oh yeah, and this is where we had all this fun with this criteria stuff before. Oh yeah, we have a trait. Good lord. With dynamic dispatch and everything. So what we were trying to do though was this is how we were trying to use it. Let's have a quick look at this. So that while I'm having dinner I can think about this. So the idea was that you've got part mapping. And then you try and match it against an EDA placement. Yeah, you see, I think if we have a sort of more generic sort of criteria thing that uses a hash map, we might not even need that trait after all this, you know. That's something to think about, isn't it? Because we defined part mapping criteria like this, right? But perhaps this should just be like done criteria. Yeah. Don't know. I'll have a think about it. All right. So just remember, folks, it's only software. How hard can it be? We'll find out on the next one.